In this video, we'll discuss an example of matrix equations applied to economics. In particular, we'll study the famous input-output model of mathematical economics, sometimes called the Leontief model, after the famous Nobel Prize-winning economist who developed it. It is one of the first great successes of mathematical economics, and it owes much of its success to its simplicity. In fact, all of the mathematics required to develop such a model we've already talked about. And because it's so simple, it can be computed. These things can be computed very easily, whether using a computer or by hand. So before we talk about the details of this actual model and construct it, let me give you some context as to where it fits into economics. So in economics, there are several main areas that people study, one of which is called macroeconomics, which is the study of sort of the big picture economics. So for example, a macroeconomist might be interested in the overall production of an economy, how an economy is growing over time or constricting over time. And so one of the central questions of macroeconomics is questions about how does an economy produce something or have a particular production. Now certainly in every economy, economies are complicated, and so there's a lot of things that are happening, a lot of variables that actually contribute to the overall output of a given economy, and therefore the overall GDP of a given country, for example. Take Canada, for example, right? So the Canadian economy can be broken up into several main sectors. So we break a huge economy into several sectors so that it's easier to see exactly how this works or how the interworkings of an economy come together. So for example, the Canadian economy can be broken into four main sectors. That is the service sector, which includes banking and retail outlets and so on. The manufacturing sector, again, when you manufacture cars or planes or trucks or boats or whatever. The energy sector, which includes, of course, oil and gas. And finally, the agricultural sector. And so the point is that within any economy, each one of these sectors depends on all the other sectors. If you add up the output for each one of these sectors, that's going to lead to the overall output of an economy. And thus we can compute the GDP of an economy that way. Now, with any production system, okay, when we're talking about production of each one of these sectors, some of the production is consumed by the production process itself. What do I mean by that? Well, take agriculture, for example, that sector. Now, agriculture for the Canadian economy produces some kind of output, right, per year. But every time that you have some kind of output for agriculture, the output depends on, for example, the energy sector. Because of course, if you want to bring your crops to market, you want to actually harvest your crops, right? All of that requires you to use fuel in the trucks and in the harvesters. And so, in some sense, energy, the output of energy is sort of an input for agriculture, right? Because the energy sector, the output of energy sector is usually gasoline or natural gas or whatever it happens to be. So an output of energy is an input of agriculture to produce an output of agriculture. Similarly for manufacturing, clearly the farmers need to harvest the material in their fields. Similarly, they need to take their crops once they've harvested them to market, and so they need trucks and they need harvesters. Well, these are produced in the manufacturing sector. Okay, those are productions out of the manufacturing sector, but they're in some sense inputs into the agricultural sector, right? Similarly, a farmer may need to borrow money from the bank in a loan to either buy crops, seeds for planting his crops, or for machinery that he may need. And that's, of course, a production of the service sector. Again, banking is in the service sector, so that's an input into agriculture as well. So the point is, for each one of these sectors, there's a bunch of inputs which comes from other parts of the economy. And so this same idea of input and output has to do with all of these particular sectors. Every sector requires some kind of input in order to produce the output for that sector, okay? And so when I put all of this together, you can see why the model that we're trying to construct here, try to understand this interworking relationship, it's called the input-output model because that's what's happening here. There's some inputs and there's some outputs. And what we want to do is we want to understand how these different sectors, again, relate to one another within some kind of dynamic economy. Okay, and that, again, is going to correspond to an overall production of the economy. Okay, the production, of course, is broken into all of these different sectors. And what we'll do, you'll see very simply, we can create a very simple matrix equation that can be used to model an economy such as this, and to understand, again, the interworking behavior between all of the different sectors of an economy. So now let's look at a simple example to understand how we construct an input-output model. So in particular, here's the simple model. Very simple economy here with only three goods: steel, food, and labor. So say that one new unit of steel requires 0.4 units of existing steel, requires 0.5 units of labor. Again, this sort of makes sense because we have to have some kind of labor to actually create a new unit of steel. Okay, so in other words, these are the inputs, this is the output. So for one new production here, one new unit of steel requires the input of these other two units here. One new unit of food, production of food requires, well, somebody's got to make the food, right? And you have to start with yeast or some kind of food to make new food. So again, here's the output. One unit of this sector is going to require as an input 0.1 units of food and 0.7 units of labor. Similarly, this third sector of the economy, one new unit of labor is going to require 0.8 units of food. You got to feed your labor. 0.1 units of labor and 0.1 units of steel. We got to have some steel work to actually do something with. Okay. So again, the red box indicates all the inputs and the output. These are the three sectors of my economy. So to produce one unit of output for each one of these sectors, it's all of these inputs that are required. Okay. It turns out that we can conveniently encapsulate all of this information into a matrix. Okay, so we'll write down a matrix next. So now I've encapsulated all of that information into one single 3x3 matrix. That is, I've encapsulated all the inputs and all the output information for this given economy and for all the different sectors. The matrix that corresponds to this collection of data is called the input-output matrix, of course, because it encapsulates the input and output information. So for this 3x3 matrix, this column corresponds to the steel. The columns correspond to the inputs of each sector, and the rows correspond to the outputs. And so you can see, for example, that for the sector of steel, it required an input of 0.4 units of existing steel, 0 units of existing food, and 0.5 units of labor as an input. And similarly for food and labor. Okay? So that's what's called the input-output matrix. And another kind of matrix required for this kind of model is what's called the production matrix. It's going to be a column matrix. It's 3x1 in this particular case. And it has to do with how much we're producing for each particular sector. So S stands for steel, F for food, and L finally for labor. So it turns out that we can multiply these together, and we now know how to multiply matrices together. So if I multiply A by X, again, this is a 3x3, this is a 3x1. When I multiply them together, I get a corresponding 3x1 matrix, which is going to be a column matrix. This has a special meaning. This actually is going to be the amount consumed. In some sense, it's the amount that the economy consumes by itself, right? So the economy is going to produce so much output, but there's a certain percentage of the economy, or the certain percentage of the output of the economy that will be consumed by the economy itself, right? And whatever's left over is the overall output of the economy that can be used to calculate GDP, okay, growth of the economy, for example. So let's multiply these together, and you'll see exactly why it actually gives you, it means the amount consumed for each particular sector of the economy.